Hey everybody. Now that we have learned the quotient rule, I notice that people try to use the quotient rule every single time they see a quotient. And while you can do the quotient rule in these cases, there are many times where you can avoid the quotient rule by simplifying the function first. So you basically have options, and I'm going to encourage you to use the most efficient option whenever possible. Let me show you this example. If we're given this function and we are asked to find the first derivative, you have two options in this case. So one option would be to go ahead and do the quotient rule. So let's do that now. So we have the function on the bottom, which is the square root of x, and you might want to go ahead and think of the square root of x as x to the 1/2 power and rewrite it with the exponent. So the bottom function is x to the 1/2, that's our low. We multiply that by the derivative of the top, which would be 4x plus 4. Remember that the derivative of the 6, since 6 is a constant, the derivative of 6 is going to be 0. So that's our low d high minus our high, which is the numerator function, 2x squared plus 4x plus 6, times the derivative of the denominator. So we use the power rule, 1/2 x to the negative 1/2, all divided by the denominator squared, which if we take x to the 1/2 and square it, that will actually become x to the first power. So at this point, you would have two options. One option would be to simplify the numerator by distributing. So you could certainly distribute in the x to the 1/2, and then over here you would also have to distribute in the 1/2 x to the negative 1/2. That's one option. Your other option would be to factor, and you could really do either one here. It's not going to matter. I'll go ahead and just show distributing because I think most of you would distribute. So you do have to be careful here and make sure that you're paying close attention to your exponents. So when we distribute x to the 1/2 times 4x, we have to add those exponents. So that is going to be 4x to the 3/2 power plus 4x to the 1/2 power. And then I'm not only going to distribute the 1/2 x to the negative 1/2, but I'm also going to think about distributing that subtraction as a negative. So therefore, I would end up with a negative x. Now remember, we're adding these exponents, so 2 plus negative 1/2. So think of 2 plus a negative 1/2. Sometimes people actually need to do the common denominator off to the side. There's nothing wrong with that if you need to work on those fractions to be sure you're accurate. So that is going to be x to the 3/2. Then we have the 4 times the 1/2, which will be 2. And then x to the first times x to the negative 1/2 would be x to the positive 1/2 power. And then plus the 6 times the 1/2. Let's go back. That's not a plus. Sorry. We are distributing the negative. So that's a minus. 1/2 times 6 is 3, and that would be x to the negative 1/2. All divided by x. And now we combine like terms. So does anything combine here? It looks like we have 4x to the 3/2 minus x to the 3/2 there. So that's going to give us 3x to the 3/2 power. And then we have a 4x to the 1/2 minus 2x to the 1/2. So that's going to be a positive 2x to the 1/2. And then we have that minus 3x to the negative 1/2 all over x. So we could simplify this a bit further, but for right now, I'll leave it as is. That is demonstrating how we could use the quotient rule in this scenario. However, I'm going to take the same exact function and show you how we could do this problem much more quickly by actually not doing the quotient rule. So let me erase over here and take the same exact original function. So our original function, in this case, because you're dividing by a quantity that just has one term, so I'm talking about the square root of x down here, that is a monomial, meaning it just is one term. When you're dividing with just one term, you can do term by term division and simplify first. So this is essentially the same as taking the first term, 2x squared, and dividing that by the square root of x, the second term divided by the square root of x, and the third term divided by the square root of x. And this is the strategy we used earlier in the chapter when we first learned the power rule. This is exactly what we did on several examples, but sometimes we lose sight of this algebraic simplification. We lose sight of it as an option when we learn the quotient rule, because then our mind just starts to see a quotient and think we should automatically dive into the quotient rule, when I think it would be much faster to actually simplify first with term by term division. So at this point, remember, you are dividing, therefore we're going to subtract our exponents. So we would have 2x to the 3/2 power plus 4x. This is 1 minus 1/2, so that would be to the 1/2 power. And then this last term, you can think of it one of two ways. There really is an x to the 0 here, so if you did subtract your exponents, 0 minus 1/2, you would end up with a positive 6x to the negative 1/2. I typically just think about it as rewriting it and bringing that denominator up to the numerator, therefore the exponent becomes negative. Now we haven't done the calculus yet, all we've done is the algebra, but now what we have is a function with 3 individual terms that are being added to each other, so we can just compute the derivative of each one separately. So 2x to the 3/2, the 2 is a constant multiple, so it just stays in front, and then the 3/2 comes in front, we subtract 1 from the power and get 3/2 x to the 1/2 power. Then the 4 stays in front, and again, power rule, the 1/2 comes in front, we subtract 1 from the power. And the 6 stays in front, power rule again, negative 1/2 x, subtract 1 from the power gives us a negative 3/2 for our exponent. So when you simplify, we would end up with 3x to the 1/2 plus 2x to the negative 1/2 minus 3x to the negative 3/2. Now looking at this answer and comparing it to our previous answer, they don't look equivalent initially. But if we go back to our previous answer and again see that we are dividing by x, which is a monomial, so if we were to simplify further and do our term by term division and divide every term in the numerator by that x in the denominator, we should get the same answer. So here we would subtract our exponents. So 3/2 minus 1 would be 3x to the 1/2 power. And then we have 1/2 minus 1 for the exponents, so that's 2x to the negative 1/2. And then negative 1/2 minus 1 would be 3x to the negative 3/2. So with a little simplification, you'll see that you do get the same answer. But in my mind, you get the same answer with a lot less work by doing it the second way, where we don't do the quotient rule and we instead do that term by term division. So the purpose of this video is to help you kind of see there are circumstances where you don't have to do the quotient rule. And in fact, the quotient rule takes longer and is more work. And I think there's some more room for error when doing the quotient rule, frankly. And I would much rather you realize that you could simplify before doing the quotient rule. Let me show you one more quick example. Another great example where the quotient rule is going to be unnecessary is when you have a constant divided by an expression. For example, 4 divided by x cubed. So this is a quotient, so you could do the quotient rule, which would be low, which is x cubed, d high, derivative of 4 is 0, minus the numerator, 4, times the derivative of the denominator, 3x squared, all over the denominator squared, so x cubed squared. And then we see that 0 times x cubed is 0, so we would end up with a negative 12x squared over x to the 6th, which if you were to go ahead and simplify, you could either leave that as negative 12 over x to the 4th, or Of course, that's the same as negative 12x to the negative fourth. Both would be acceptable forms of the derivative. Now, there's nothing wrong with the work I just did with the quotient rule, but what my argument is here is that that's not the most efficient way of tackling a function that looks like this. Because if the numerator is just a constant, we could technically take this denominator, rewrite it in the numerator. So we're going to algebraically rewrite the function first. So that would make it 4x to the negative third power. And now there is no quotient at all. And it would be so fast to just do your power rule. So the 4 stays, and you multiply by the derivative of x to the negative 3, which is negative 3x. Then you subtract 1 from your power. So that would be negative 4. And you very quickly get the exact same answer of negative 12x to the negative fourth power with a fraction of the work. So 2 great examples I want you to be aware of. The fact that the quotient rule is great and very needed in some settings, but there are definitely some functions where you don't have to use the quotient rule, and you will save yourself time and energy and maybe a little frustration if you can recognize the functions where you don't have to use the quotient rule. You could simplify the function first or perhaps rewrite it, and then you can avoid the quotient rule altogether. I hope that helps.